Hello 6th grade class. Today we're going to be doing geometry in 3 dimensions and real life applications. To introduce the topic, we're going to do the differences of the 2D shapes and the 3D shapes. So to begin, 2D shapes have only the height and the length, 2 measurements, and 3D shapes only have the length, height, and width. And some differences are 3D shapes are solids and 2D shapes are flat figures. So for some examples of these two things are 2D shapes are triangles, squares, circles, anything flat that you can think of is a 2D shape. And 3D shapes are examples are cylinder, cone, cube, sphere, pyramid, and prism. So to begin, we're going to do some important terms we need to know to understand the lesson. So to begin, we have simple closed surface. A simple closed surface is a one interior, which is hollow or empty, and one exterior has no holes. So it means pretty much any figure, it has no opening and it's just hollow and empty in the inside. The next one is a solid. A solid is the set of all points on the surface as well as all of the interior points. So that means it's just a solid. You could hold it. It's not flat. Okay, to begin, we're going to do our first shape. Our 3D shape is a sphere. The set of all points that are a certain distance away from the single point. And here's a picture to better understand it. This is a picture of a sphere. Obviously, you can't see. It's a 3D shape though, and the distance from the center to the sphere is called the radius of the sphere, which is this little part. It means the amount of distance from here to there, pretty much. And this is just a printed picture of the sphere, but you could see it's 3D. Okay, that's one. Then we're gonna go ahead to polyhedrons. A polyhedron is a simple closed surface with sides that are shaped like polygons. For example, polyhedrons have faces, vertices, and edges. And this is a picture of a polyhedron, which you could tell it has a vertices, an edge, and a face. So every time you're trying to determine a polyhedron, you have to point out, does it have edges, vertices, and a face. To better understand that, we're going to do some examples of a polyhedron. And here are 4 examples of a polyhedron. So to begin, let's look at the first example. We have a face. Do we have edges? And do we have vertices? So let's break it down. Does this have a face? Yeah. Does it have an edge? It does. And then it has vertices. We have one here, one here, one here. So yes, that's a polyhedron. Next picture, we have, let's determine if we have all the 3 things to determine. We have a face, we have an edge, and we have vertices. So yes, that's another polyhedron. Now we have a cylinder. So does it has edges, but it doesn't have any vertices. So that's not considered a polyhedron. And now we have a sphere. As you can tell, a sphere doesn't have a face or any edges or any vertices. So no, that wouldn't be considered a polyhedron. So every time you're trying to determine a polyhedron, you have to point out the 3 things to determine if it is. Next example we have is a prism. A prism is a polyhedron with 2 congruent parallel bases, and the other faces are shaped like parallelograms. And when it comes to prisms, there's 2 different prisms you can name. So there's a right prism, which is a prism where the lateral faces are rectangles, and then there's oblique prisms with prisms where the lateral faces are parallelograms. And then a thing to remember is prisms are also named by shapes of the bases. So here I have a picture of a prism, and you could tell that it has a face, it has vertices, and it has edges. So that's that's why it's called a polyhedral as well. So a prism is just a triangle, and yeah, that's a picture of a prism. And now we're gonna do examples of prisms to better understand what are prisms. So to begin, we have this cubed-like shape. So let's determine if it has two congruent parallel faces, which it does, and has other faces like parallelograms, which it does. So this is considered, since it's a square, it's a right square prism. Now let's look at the second one. Does it have two congruent parallel faces? It does, because there's one here and one here, and parallelograms again. So this is the shape of an octagon. So this is going to be an octagonal prism. Next one, we have a two congruent parallel faces, which it does. It's one here, good. And other faces are shaped like parallelograms. It works. So this is an oblique prism, which is the definitions right here. So it has a face of a parallelogram. And then the last one we have is does it have two congruent shapes? It does over here and up here. So this one will just be considered a right prism, since when we saw the definition up here, it says prisms where the lateral faces are rectangles. These are rectangles, so it's a right prism. So that's that. And now we're gonna go into pyramids, which is our last 3D shape we're gonna talk about today. We have a polyhedron determined by a polygon faces, which can also be called a base, in a point of an apex, not in the same plane as at the face. So to remember with pyramids, just remember that pyramids are named by their bases. So here we have a picture of a pyramid, and to do some vocab about the pyramid, the little tip point up here, it's called the apex, and then obviously this little shape right here is the base. So every time you're looking at pyramids, try to determine the base and the apex, which is pretty simple since there's only one top and the base is pretty straightforward. The pyramid shape comes from the triangular faces. Lateral faces are also called lateral faces, which is that, here, they're all lateral faces, determined by the point of each edge of the polygon, which is the base. So whenever you're trying to determine a pyramid, just remember to identify the apex, the base, and if it has lateral faces, which it obviously does. Okay, that concludes the vocab and the pictures and examples to determine our fun activity we have for later. But first we're going to do some connections to real life, which we have real life applications. So real life application basically means where do we find this in the real world. So I brought some things from home to better understand the lesson and to see a picture to something. So here I have is I would ask the class, what is this? And be a sphere. It's a globe, it's a sphere, it's a perfect circle as you see, and I'll just keep asking the students like, does it have faces or does it have edges? And obviously it doesn't, so just to better understand the lesson, I'll ask those little questions in there. And then I have here is a dice, which we use to play games. And this is obviously a 3D shape. It has edges, vertices, and faces. So just better understanding, I asked the class to determine those three things. Then I have a Diet Pepsi, which is a cylinder. Since it's a closed surface, there's no end, it's empty. Obviously not, but just to determine like it's a one shape and it's hollow and it has a solid simple closed surface. And then the last one I have is a Pringles can, which is a cylinder, and it's a simple closed shape as well, since there's no openings, it's closed and it's just there. So then after that, I would ask the class to look around the classroom to determine some real life applications or some examples they could come up with at home, and just say out loud as a group. Okay, and finally, I put together a little activity to understand more of the lesson. So I have a baggie filled with shapes and names, so the class can divide into small groups, and each group would have their own bags, and they'll just work together to determine which ones are prisms, which ones are none, like it doesn't follow, sphere, polyhedrons, and they just have all these choices, and as together as a team, they'll put them all together, and after that, as a class, we'll review it, and if anyone has more questions, we'll answer them, but that's it.